All right, we're going to go over the AP Calculus free response questions. We're going to do AB. Uh, what is first? Is it no calculator? Yes, we're going to do AB, yes calculator, and then BC, yes calculator, then AB, no calculator, then BC, no calculator. This video is provided as a service of World's Finest Physics. We do physics and math stuff. We do tutoring for students, and we're also going to try and make some extra practice for students for physics and math. And we do professional development for physics and math teachers because physics uses a lot of math and math involves a lot of physics. So we figure they just might go together. So if you're interested, if you come across this video, want to know more about it, you can visit our website. All right, so AP Calculus AB, let's have a look here. Number one, an invasive species of plant appears in a fruit grove at time t equals 0 and begins to spread. The function C, now is this the same one as on BC? Because some of them are shared. Yes, okay, so this is number one for both AB and BC. Okay, the function C defined by this models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that that is the derivative. Okay, find the average number of acres affected by the invasive species from time 0 to time t equals 4 weeks. Show the setup for calculations. Okay, so I think that to find an average number, and it says that this is the number of acres, that's C, so I want the average from 0 to 4, then you take the integral over the interval. So for A, we're going to take the integral of C of t dt from 0 to 4 over the interval 4 minus 0. Okay, so I'm going to just do that on the calculator. Let me go ahead and show integral from 0 to 4 of 7.6 inverse tangent of 0.2 t dt all over 4, basically, right? Okay, so let me get my calculator here. Just got stuck in a box there. Okay, so what I'm going to do here is I'm going to go to math. I'm going to do function numerical integration from 0 to 4 of 7.6. Let's make sure my calculator is in radian mode. I'm usually in degrees because we don't normally use degrees in physics. Inverse tangent of 0.2 t, or x in this case, dx. And then we're going to take that number and we're going to divide it by 4. So it's 11.11 divided by 4. 11.11 divided by 4, which is 2.778 acres. I feel like I showed the setup for my calculations. All right, got to clear my throat here. Okay, find the time t when the instantaneous rate of change c equals the average rate of change of c over this interval. Okay, so what is the average rate of change? The average rate of change is going to be c at 4 minus c at 0 over 4 minus 0. Okay, so I might as well just enter c into my calculator here. Okay, so it's going to be 7.6 inverse tangent of 0.2 t. Okay, all good. Well, let's enter in the derivative just for the heck of it. Okay, I might use that plus t squared. Okay, so all good. All right, so I'm going to do y1 at 4 minus y1 at 0. Okay, so 5.12. So this is 5.128 over 4. So let's divide that by 4. Okay, so that's 1.282 acres per week. Okay, so that is the average rate of change. Now, the instantaneous rate of change is the derivative. So when is C prime equal to 1.282? Right? That's what we want to know. So we're going to say 38 over 25 plus t squared is equal to 1.282. Now we can cross multiply. We can do 38 over 1.282 equals 25 plus t squared. So I'm going to do 38 over this minus 25. Okay. And so t squared is equal to 4.64. So we're going to just take the square root of that, and we don't have to do plus or minus because it's going to be, okay, so it's going to be t equals 2.15 weeks, 2.154 weeks. All right, so that's the best answer I can give you on B. I hope I'm correct because I'm doing this all sight unseen. Okay, C. Assume that the invasive species continues to spread according to the given model for all times greater than 0. Write a limit expression that expresses the end behavior of the rate of change, the end behavior of the rate of change in the number of acres affected by the species, and evaluate this limit. the end behavior of the rate of change. That's the derivative. So we're asking for the limit as t goes to infinity of 38 over 25 plus t squared, and that winds up equaling 0. And of course it equals 0 because eventually you're going to have all of your acres invaded, right? And then you're not going to get any more acres invaded by your species. Okay, at time equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. Okay. Function A, defined by that, models the number of acres affected by the species over the time interval 4 to 36. At what time does A attain its maximum value? Okay, so A attains its maximum value when its derivative is equal to 0. So A is equal to C, A of t is equal to C, 7.6. I'm getting allergic to all this calculus. 0.2t, okay, minus the integral from 4 to t of 0.1 natural log x dx. I need to take the derivative of this. So the derivative is going to be this derivative up here, 38 over 25 plus t squared, minus the derivative of the integral is himself, 0.1 natural log of t. Okay, and we want to know when this is equal to 0. Okay, so make equal to 0 to maximize, make a prime equal 0 to maximize a. All right, so now what I'm going to do is I'm going to go here to this derivative function, but I'm going to add this negative 0.1 natural log t, this negative 0.1 natural log t, okay, and as we look, when is it going to equal 0? It's going to equal 0 sometime between 11 and 12. So what I'm going to do is I'm going to only turn this guy on, and what was this is going to equal 0, so I don't really care. So let's go from 0 to 20, okay, let's calculate a 0. Okay, so here's the function. Okay, are we seeing that there? All right, so there you go, left bound 11. Right bound 12. Guess whatever. Don't care. 11.2, 11.442. So at t equals 11.442 weeks, the amount is maximum. Right? Okay. So now that was for both AB and BC calculus. This is going to only be for AB calculus. Then we'll do the one that's specific to BC. The shaded region R bounded by the graphs of functions f and g, where f is this nice smooth parabola and g is this weird sign that looks like my heart when I take a blue pill. So find the area of R. Okay, so I'll just do that up here. So the area of R is going to be the integral, and the function that's on top is g. So it'll be x plus sine pi x, and then minus the parabola, x squared minus 2x. How many parentheses do I need? Dx. Looks like we're going from 0 to 3. So we're going to go from 0 to 3. And frankly, I have a calculator, so why don't I just go ahead and calculator it? Okay, so here we go. So we have x squared plus 2x x plus sine pi x. Okay, I'm sure that there's an exact way to do this, but I don't care. Okay, so we're going to take a function numerical integral. Okay, and this is going to be from 0 to 3, and it's going to be y2 on top minus y1 on the bottom. Oops, I did not put my x there. Okay, so what do we got? Negative 12. What did I do wrong? Hold on a second. X plus sine, oh, there's supposed to be a minus here. Sorry. Okay, so there's supposed to be a minus there. Okay, so let's get this correct. Okay, 5.13. Okay, so 5.137 is the area. Great. Okay, so the region R is the base of a solid. For this solid, at each x, the cross section perpendicular to the x-axis is a rectangle with height x and base in the region R. Okay, so the rectangles are actually getting progressively taller, right? So if I was to draw a picture of this, x and y, and you've got, and you've got, then the rectangles would be getting taller, 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 okay, where the height is x and the base would be G minus F. So the base would be G minus F. Okay, so volume is integral of the area of the thing, dx, because the thickness is a little dx. Okay, do you see that? The thickness is a little dx. Okay, so thickness is a little dx, and now the area is A. Now, what is the area? The area is going to be G minus F times x. That's the area, and then dx. So that's height, and that's base. Height times base. So, and then we're going to integrate from 0 to 3, 0 to 3. Okay, so we're going to integrate. The volume is going to be integrate from 0 to 3. Okay, what is G? X plus sine pi x, okay, minus x squared minus 2x. Okay, so that's G minus F times x dx. Okay, so now really all I've got to do is just take this and I'm going to do y2 minus y1 times x dx. All right, and I get 7.77. So the volume I get is 705. All right, so that's the volume that I get. Okay, just making sure that I'm not crazy. That seems right. Base times height, dx. So that has units of volume, all right. Okay, so let's go on to C. Right, but do not evaluate an integral expression for the volume of the solid generated when the region R is rotated about the horizontal line y equals -2. Okay, so this is going to be a Schwager method. Okay, and the inner radius is going to be F, and the outer radius is going to be G. So the shell method is, the washer method is this. It's, let's see, the volume of a cylinder is area of the base, pi r squared times h, okay? And so the tiny volume of the cylinder is going to be pi r squared times the tiny height, which is dx here. That's a little tiny thickness, right? And then because it's a hole, it's actually r squared minus a little r squared. I have to rederive that every time. So we're going to do pi. We're going to integrate from 0 to 3. And the big R is going to be g of x squared minus f of x squared dx. Okay, so this is going to be v equals pi integral 0 to 3. Okay, so g of x plus sine pi x squared minus x squared minus 2x squared dx. Okay, so I've already done something like this in my calculator. Will it allow me to do that? Y squared minus y1 squared. And then I can get rid of this parentheses and this parentheses. Okay, will it do it? It will do it, and then I need to multiply by the pi that's out in front. So then I get a volume. Oh, I was not supposed to actually evaluate it. Sorry, never mind. Okay, so never mind. It can be shown that the first derivative, can people not just take derivatives on their own? Like you can take the derivative on this one too. It's like it can be shown that. Well, okay. All right, thank you for giving me the derivative of g. Find the line, the value of x, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. Okay, so in other words, find where g prime equals f prime on, and there's x less than 1. Okay, so f is x squared minus 2x, so f prime is 2x minus 2. Okay, so we're going to find where 1 plus pi cosine pi x is equal to 2x minus 2. Okay, so let's go ahead and just subtract those two functions and find where they're equal to 0. Okay, so 2x minus 2, okay, in parentheses, and then minus 1 plus pi cosine pi x. Okay, and now let's set the window 0 to 1. Is there a clear place where it cross over? It looks like there's gonna be. Okay, so let's go ahead and calculate a 0. Sure, that can be the left bound. Let's make the right bound 1. I really don't care. It'll find it eventually. 0.675. Okay, so at x equals 0.676 actually is where the derivatives are equal to each other. Okay, now let's look at what the BC kids had to do. They had to do a polar function here. Curve C is defined by the polar function that, okay, and curve C is a semicircle. Wait a minute, what? Oh, curve C and this. I'm getting allergic. Excuse me. Jeez. Okay, I'm really allergic to polar functions. Dang. Okay, curve C and the semicircle. I thought they were calling this curve C also. It's like you can't name something the same thing twice. That's ridiculous. Okay. Are shown. Okay. Your calculator should be in radian mode. Thank you. Thank you for telling me that. Find the rate of change of R with respect to theta at the point on curve C where theta equals 1.3. So the rate of change of R with respect to theta, so that's just the derivative of this. So if R is 2 sine theta squared, then we bring down the power, 4. The inside stays the same, sine, and then we multiply by the derivative of the inside, cosine. So R dr d theta is that. So dr d theta evaluated at theta equals 1.3 would be 4 sine 1.3 cosine 1.3. All right, well, let's just go find out what it is. 4 sine 1.3 times cosine 1.3 and 1.031. So 1.031. Okay, find the area of the region that lies inside curve C, but outside the graph of the polar equation, R equals 1/2. Show the setup for your calculations. Okay, so the first thing I need to do is I need to know where, let me change colors for this. I need to know where this is. What is this value of theta? And I'm assuming that's just going to be the same value of theta on the other side. So when are these equal to each other? When is 2 sine squared theta equal to 1/2? Well, then that's where sine squared theta equals 1/4, which is where sine theta equals 1/2 or negative 1/2. So that's theta equals pi over 6, also known as 30 degrees. Okay, so that means that we're going to go from pi over 6 to 5 pi over 6. So now the area is, let's see if I can remember it, 1/2. Is it r squared d theta? It is, isn't it? Right? Let me just rederive it really quickly. Okay, so if I have a little segment here, and the segment is theta, and this is r, then the area of the segment over pi r squared is equal to theta over 2 pi. Okay, so the pi's cancel, and I get area equals 1/2 r squared theta. So then area would be 1/2 the integral of r squared d theta, and that's going to go from pi over 6 to 5 pi over 6, okay? Oh, and I have to subtract this actually, so never mind. It's going to be r squared minus 1/2 squared d theta, right? Okay, so it's going to be this area, r squared, minus this area, 1/2 squared. So let's go ahead and do that really quickly. We're going to do 1/2 times math, the integral function numerical integration from pi over 6 to 5 pi over 6, okay? And then r squared, so that's going to be 2 sine x, then squared, and then that itself needs to be squared. So that itself needs to be squared, minus 1/2 squared dx. All right, so what is this area? I think the area is going to be 2.067. That's what I think it winds up being. All right, does it say I have to give exact values? Okay, whatever. Okay, moving on. It can be shown that dx d theta is that for curve C. For that, find the value of theta that corresponds to the point on curve C that is the farthest from the y-axis. Okay, so for C, farthest from the y-axis equals the maximum x, which means dx d theta is 0. All right, so let's just set this equal to 0. 4 sine theta cosine squared theta minus 2 sine cubed theta equals 0. Okay, so we're going to factor out a sine, and we're left with 4, we can factor out a 2. 2 cosine squared theta minus sine squared theta. Okay, so either sine is equal to 0 or this is equal to 0. Let's see. 2 cosine squared theta minus sine squared theta equals, I feel like this is going to be 45 degrees, because I'm going to say 2 cosine squared theta equals sine squared theta. So that means 2 equals tan squared theta. So I guess square root of 2, that's not what I thought it would be. I thought it would be 1 over radical 2. Okay, so 2 equals tan theta radical 2. So theta equals the inverse tangent of radical 2. What is that? What is the inverse tangent of radical 2? Inverse tangent of radical 2 is 0.955 radians. So 0.955 radians. Okay, so where is that? That would be, I believe that. That looks like an entire radian. It's a little bit more than 45 degrees. Okay, I guess I believe that. Okay, now, D. A particle travels along a curve C so that d theta dt is 15 for all times t. Find the rate at which the particle's distance from the origin changes, so the rate at which r changes with respect to time when the particle is at the point theta equals 1.3. Okay, so find dr dt at theta equals 1.3. Okay, so r is 2 sine squared theta, and we found out that dr d theta, we did that already, didn't we? 4 sine theta cosine theta, we already did that once. So then that means dr dt is dr d theta times d theta dt, which is 4 sine theta cosine theta d theta dt. So all this we already found as being 1.031 from before. We found that on part A, okay? And then d theta dt, we're told, is 15. So we're just going to take that 1.031 and we're going to multiply it by 15, and you get 15.465. That is dr dt. Okay, so that was for the BC kids. Now, let's see. The BC students are going to have a student starts reading a book and a continuous function f. Let's see what the AB students have. Yep, they have the same thing. So this is going to be AB and BC. Let's look. A student, and I'm not allowed to have a calculator, so let's see how I can do this. Okay, student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. Okay, it's better than my kids. The rate at which the student reads is modeled by a differentiable function r, or r is measured in words per minute. Okay, approximate r prime of 1 using an average rate of change of r prime over the interval, show work, and include units of measure. Okay, so r is in words per minute, so then r prime would be words per minute squared. So r prime of 1 would approximately be 100 minus 90 over 2 minus 0, which is 10 over 2, which is 5 words per minute squared. Okay, so he's speeding up in his reading, apparently. Okay, so that was A. Must there be a value of C from 0 to 10 such that the original R is 155? Oh, that R is 155? I'm going to say yes, because so I'm going to say yes. There must be a moment when R of C is equal to 155, and that is since in going from t equals 0 to t equals 10, R goes from less than 155 to greater than 155, and R is continuous since it is differentiable. If you are differentiable, you're automatically continuous. Okay, C. Let's see what's going on here. Use a trapezoidal sum with 3 subintervals indicated by the data in the table to approximate that. Okay, so the trapezoidal rule is this. We're going to do the area. Okay, area is approximately equal to. Um, okay, so the area of a trapezoid is the average of these two times the difference of these two. So it's going to be 2 times 95. Okay, so 2 times 95 plus, what is that, 6 times 125, and then plus 2 times, what is the average of these two? Gosh, I really don't want to have to do this. It'd be 156, wouldn't it? 156, okay. So then 2 times 100 is 200, so this I got to be 190. Okay, so this will be 750, I believe. Yeah. And then this is going to be whatever the frick this is. Okay, so 312, 312. Okay, so that's going to be 2. All right, and then 1, 5, and 9 makes 5. Carry the 1, so 4, 5. I guess 12, 52. I'm going to use my calculator just to make sure I'm right. I know I'm not allowed it, but shut up. Okay, so plus, what was it? 6 times 125, and this is assuming I did the averages correctly. Okay, 1252. Okay, and then this will actually be a number of words. So this is a number of words. D. A teacher also starts reading at time equals 0 minutes and continues reading 10 minutes. The rate at which a teacher reads is modeled by the function W, is words per minute also. Based on the model, how many words has the teacher read by the end of 10 minutes? Okay, so if this is words per minute, then we just have to take the integral of this. So the number of words will be the integral from 0 to 10, negative 3 over 10 t squared plus 8t plus 8t plus 100 dt. Okay, so now we're going to raise up the power. We're going to divide by the new power. Okay, so 1/10. Raise up the power, and divide by the new power. We're going to raise up the power and divide by the new power, which is 1, and we're going to plug in 0 and 10. Plugging 0 into a polynomial gives you 0. Plugging in 10 is going to give you 1/10, negative 1/10 of 1,000, so that's negative 100. And 4 times, thank you for this being just such pretty numbers. I'm so happy about that. Okay, pretty numbers make me happy. Okay, so 200, no, sorry, 1,000, 1,000, 1,000. Okay, so that's 400, 1,000, and negative 100. I'm just double checking. I'm not using my calculator, so I'm really hoping I'm doing this right. 1,300 words. So she reads about as well as this kid does. And she's a teacher. Okay. A continuous function f is defined on the closed interval, whatever. The graph of f consisting of two symmetrical one line segment is shown. Let g be the function defined by g is the integral from 6 to x f of t dt. Find g prime of 8. Okay, well then g prime of 8 would just equal f at 8, because that's one of the fundamental theorems of calculus. The derivative of an integral is itself. This is f, so f at 8 would be 1. That's part A. Find all values of x in the open interval that, at which g has a point of inflection. Okay, so B, the inflection means g's second derivative changes sign, which means f's first derivative changes sign. So from negative 6 to 12, when does the derivative change sign? When the slope goes from negative to positive, that's x equals negative 3. Well, I think it's also when g changes sign or is undefined, So I don't know. Do I count this? I don't know. I don't think that's a point of inflection, because what would g look like at this point? It would be g would be its slope would be decreasing and decreasingly negative, and then increasingly positive. I don't think that's a point of inflection, because that is so no. The derivative is undefined here because it's straight up and down. So I'm going to go for x equals 3, and then I'm going to say x equals 6. Those are the points where the derivative of f changes sign. Okay, you may need to make a comment about that if 0 counts, because that's where the derivative changes sign, but g itself would have a less and less and less negative slope, then more and more positive slope, so that the concavity doesn't change. Okay, C. Find g at 12 and g at 0. Label your answers. Okay, so g at 12 is the integral from 6 to 12 f of t dt. So that's the area of f from 6 to 12. So from 6 to 12, that's going to be 1/2 times the base of 6 times the height of 3. Okay, and that's going to be 9. G at 0 is going to be the integral from 6 to 0 f of t dt, which is going to be the opposite of the integral from 0 to 6 f of t dt. So it's going to be the negative area from 0 to 6. And so that's going to be half of pi times the radius of 3 squared. So that's going to be 9 over 2 pi. Negative 9 over 2 pi. Negative. Okay, all good. And then D, find the value of x at which g attains an absolute maximum on the closed interval. Okay, so here's what I'm going to tell you, folks. What I'm going to tell you, folks, is that I can just intuitively know that the answer is at x equals 12. And here's how I know. I know that because because g of x is increasing from x equals 6 to x equals 12, since f of x, which is g's derivative, is positive. Okay, so g must be increasing because this f is a positive number. Now, what am I going to say? Now, going from x equals 0 to x equals 6, g is also increasing since g prime, which is f, is a positive. So that means that g is going up, 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 up. So this must be the absolute maximum. Now, what about this? Well, and then going from x equals -6 to x equals 0, g of x goes down the same amount it goes up, x equals 0 to x equals 6. So in other words, g is going to go down. So this could be the maximum if you go down from the maximum, right? But it can't be the absolute maximum because you go down and then up the same amount. Then you go up even more. So if you go up even more, this has to be where the absolute maximum is. Okay, that's my story and I'm sticking to it. All right, this is the number 5 for AB students. Two particles, H and J, are moving along the x-axis. For this interval, the position of H is given by that, and the velocity of particle J is given by that. So we're given the position of one and the velocity of the other. Find the velocity of particle H at time equals 1. Okay, so that's just the derivative. So velocity of H is dxh dt. This is physics, so it's definitely up my alley. So the derivative of E to anything is himself, but then I have to multiply by the derivative of what's in the air. Okay, what is the V of H at time 1? That's going to be 2 times 1 minus 4 is -2. 1 squared minus 4 is -3. All right, I'm leaving it that way. That was part A. All right. During what open intervals are particles H and J moving in opposite directions? Give a reason for your answer. Okay, so opposite directions means velocities. The VH and VJ have opposite signs. Okay, so VH, we said, is 2t minus 4 e to the t squared minus 4t. So this can never be negative. That can never be negative. This can be negative. So I'm going to say that when is 2t minus 4 equal to 0 is at t equals 2. Okay, so let's make a little sign chart here. Okay, so here we go. 0, 1, 2, 3, 4, 5, or something like that. Okay, so 2t minus 4 is going to be positive for values higher than 2. So VH is going to be positive, 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 negative, negative, okay? And then let's look at this velocity right here. 2t times t squared minus 1 cubed. Okay, 2t times t squared minus 1 cubed. Okay, so at between 0 and 1, t is positive, but t squared minus 1 is going to be negative, and it's cubed, so this will be a negative. And then 2t will be positive, and t squared minus 1 has to be positive because t is greater than 1. Positive, 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 positive. So when they're going to move in opposite directions, vj, that's going to be on the interval on 1 is less than t is less than 2. They have opposite sign velocities. Okay. All right. C. It can be shown that Vj, is there a prime there? Yeah, okay. Of 2 is greater than 0. Okay. Is the speed of the particle j increasing, decreasing, or neither at time t equals 2? So here's what I'm going to say. This is very important. If the velocity and the acceleration have the same sign, then you're speeding up. You speed up if velocity and acceleration have the same sign. Well, velocity at 2, Vj at 2 is, okay, 4. All right, is positive 4. And we are told dv dt at t equals 2 is also positive, so it's speeding up. Yes, this is it. This is definitely in my wheelhouse. I have to teach this even to non-calculus students, that if the velocity and acceleration have the same direction, you're speeding up. Okay, particle j is at position x equals 7 at time 0. Find the position of particle j at time equals 2. Show your work. So in other words, we're going to say that delta position is the integral of v dt, and we're going to integrate from time 0 to time 2. Okay, so this is going to be x at time 2 minus x at 0 is equal to the integral from 0 to 2 of 2t t squared minus 1 cubed dt. Okay, so then let's come over here. X of 2 minus 7 is equal to the integral from 0 to 2. Now, I'm going to do a u substitution here. It's u equals t squared minus 1, and du is 2t dt. I mean, it's right there for me. So this is u cubed. So u cubed du. And in fact, you know what I'm going to do is I'm going to change the bounds, because you know what? I get to do that. So at t equals 0, u is equal to -1, and at t equals 2, u is equal to the 2 squared minus 1 is 3. Okay, let's make sure we get that right. Okay, so I'm going to go from -1 to 3. So this is u to the fourth, 1/4 u to the fourth, -1 and 3, x at 2 minus 7 is equal to that. So x at 2 minus 7 is going to be 81 over 4 minus 1 over 4, which makes 80 over 4, which is 20. Gosh, these are such pretty numbers. I'm so happy. 27. I hope that I'm right about that. Is this even given in units of meters or anything? No. Okay. Last of the AB questions. Consider the curve G defined by that equation. Oh, it's an implicitly defined curve. Show that dy dx equals that. Okay, so what I'm going to do, I'm going to say 3y squared times y prime minus 2y times y prime minus y prime plus 1/2 x equals 0. So now let's collect together our y primes. 3y squared minus 2y minus 1 y prime plus 1/2 x equals 0. Move him over. So let's just say minus 1/2 x, and then divide. Y prime is going to be x, there it is, with a negative, there it is, over 2, there it is, 3y squared minus 2y minus 1, which all came from the implicit derivative. There's a point P on the curve near that with x coordinate 1.6. use a line tangent to the curve at 2, 1 to approximate the y coordinate of point P. Okay, so the way this works, we're going to say y minus y1 equals slope x minus x1. Okay, so y1 is -1, okay, and then x1 is 2, okay, and then now I need to get the slope. Okay, the slope I'm going to plug into here. So the slope is going to be -2 over 2, 3 times -1 squared, minus 2 times -1, minus 1. Okay, does that sound good to you? So these are going to reduce to 1. And then I got to evaluate this. 3 plus 2 is 3 plus 2 is 4. Minus 1 is 3. No, 3 plus 2 is 5. Minus 1 is 4. Like, I'm so zapped with the calculus, I can't even do freaking arithmetic here. 3 plus 2 is 5. Minus 1 is 4. So I get -1/4. Okay, so then this will be -1/4. So we're going to get the y coordinate by saying that this is 1.6 minus 2, so y plus 1 equals -1/4 of -0.4. So then these are going to get together and make -0.1. Y plus 1 equals +0.1. So y is going to be -0.9. Okay, that's my approximate value. All right. Okay, so for x and y greater than 0, there's a point S on the curve G, which is at which the line tangent of the curve is vertical. Find the y coordinate of point S. Okay, so that was B. Tangent line is vertical, means dy dx is undefined. So if dy dx is -x over 2, 3y squared minus 2y minus 1, then 3y squared minus 2y minus 1 equals 0. Okay, so now I have to factor this. I'm going to use a fucking quadratic formula. -b plus or minus the square root of b squared minus 4 times 3 times -1, so plus 12, so that's going to wind up being 4 all over 2a, right? Okay, so y equals 2 plus or minus 4 over 6. 2 minus 4 is negative. 2 plus 4 over 6, so y equals 1. Okay, so there you go. I can't factor. Fuck. Okay. A particle moves along the curve h defined by this equation. At the instant when the particle is at this point, dx dt and dy dt is, find dy dt. Okay, so I'm going to say 2xy plus natural log y equals 8. So then I need to do a product rule. So it's going to be 2x times y prime plus 2y times x prime. And then this will be y prime over y, okay, and then this will be 0. All right, so we're told that dx dt equals 3. So we're told x equals 4. Do you see it right there? X equals 4, y equals 1. X prime is 3. Find y prime, basically, right? Okay, so we're going to say 2, 4. Y prime, I don't know what that is, plus 2y x prime plus y prime over y, thank you for making it 1, equals 0. That's really nice. 8y prime plus 6 plus y prime equals 0. So that's 9y prime equals -6. So y prime will be -2/3. All right, so that's the end of AB calculus. Let's do the end of BC calculus really quickly here. Okay, so we did those. What's going on here? Let f of x be the particular solution to this differential equation with this initial condition. Find the second derivative. Find the second derivative. Okay, so I'm going to say this for part A. If dy dx is 3 minus x y squared, then the second derivative of y with respect to x is going to be where we're going to take the derivative of this with respect to x. So let's do a product rule. This is going to be -1 times y squared plus 3 minus x and then 2y, but then times a dy dx because that is the chain rule. So d squared y over dx squared is going to be -y squared plus 3 minus x y, and then what is dy dx? Another 3 minus x times y squared. That's it. That is that. So do you see how I did that? Okay, so let's simplify this. D squared y over dx squared equals negative y squared plus 2 um, 3 minus x squared y cubed. We're doing this at 1, negative 1. Okay, so negative 1. So negative 1 plus 2 times 2 squared times negative 1 cubed, which is also negative 1. Okay, so we have 8, but negative 8, so I guess it's going to be negative 9. So d squared y over dx squared is negative 9. Okay, write the second degree Taylor polynomial for f about x equals 1. Okay, so what am I going to say here? Okay, so f at 1 is equal to 1. So, okay, now I need to remember how to build a Taylor polynomial. I believe it is f at 1, okay, over 0 factorial, all right, x to the 0, or really x minus 1 to the 0, plus f prime at 1 over 1 factorial, x minus 1, and then f double prime at 1 over 2 factorial, x minus 1 all squared. Okay, so let's see if I can build this, okay? So f at 1 is negative 1. F prime at 1, okay, so I need to plug that into here. So this is going to be 3 minus 1 times negative 1 squared, so that's just 2. Okay, so f prime at 1 is worth 2, x minus 1, okay. And then we're going to add to it f double prime, which we've decided is going to be negative 9. All right, so plus negative 9 over 2 factorial, which is 2, x minus 1 squared. All right, well, I think I know how to build a Taylor polynomial. Why don't you rag me out in the credits or in the comments if I don't? Okay, the secondary Taylor polynomial of f about x is used to approximate f at 1.1. Given that f triple prime is less than 60 for all x in this interval, use the Lagrange error bound to show that this approximation differs from that by at most 0.01. I can't remember how to do Lagrange error bound, so I'm probably going to get this wrong. I probably should have studied that before I started this video. So I didn't look at these in advance, and I just can't remember how to do Lagrange error bounds. I do know that the next term in the Taylor series is going to be f triple prime at 1 over 3 factorial x minus 1 cubed. Okay, so we were told that this number is less than 60. So this is essentially 60 at the most. 3 factorial is 6. And this is 1.1 minus 1 cubed. Okay, so now this is 10 out in front. This is 0.1 cubed, which is 1,000th. And there's your 0.01. So that's Lagrange error bound, is just what's the highest possible value of the next term. Okay, using Euler's method, starting at x equals 1 with 2 steps of equal size, approximate f at 1.4, show the work that leads to your answer. Okay, so let's go back and remember dy dx is 3 minus x y squared, and so I'm going to say dy is 3 minus x y squared dx, okay, and we start at x equals 1, y equals negative 1. Okay, so I'm going to say that the dy is going to be 3 minus 1, okay, and negative 1 squared, and then the dx is going to be, the two steps are going to have to be 0.2. To go from 1 to 1.4, you have to do 0.2, then another 0.2. So it's a 0.2. So really this is going to be a delta y now. This is going to be a delta y. Okay, so 2 times 0.2 is 0.4. The delta y is 0.4, so f at 1.2 is approximately 0.4, and then we add the negative 1, we make negative 0.6. Okay, so now step 2. Okay, so delta y is going to equal 3 minus x, y squared, delta x. So the delta x is again 0.2. The y is going to be 0.6 squared, and then this is going to be 3 minus 1.4. 3 minus 1.2, I mean to say. So what is 3 minus 1.2? Is that 1.8? Okay, good. So that's the delta y. So then the f at 1.4 is approximately negative 0.6 plus whatever 1.8 times 0.6 squared times 0.2. I don't know what that number is. I'm not multiplying all that out. Do you think I'm multiplying all that out? You're crazy. Okay. Oh, it's more Taylor series. Yay. The Taylor series about f is given by this and converges to f of x on its interval of convergence. Using the ratio test, find the interval of convergence. Okay, so my understanding is that the ratio test is you take the limit as n goes to infinity of like an plus 1 over an absolute value, and to converge, that absolute value has to be less than 1. So I'm going to say we're going to take the limit as n approaches infinity of x minus 4 to the n plus 2 over n plus 2, 3 to the n plus 1. And then for the other one, I'm going to put that one in purple now. So that's going to be n plus 1, 3 to the n over x minus 4 to the n plus 1. That almost completely cancels here. This almost completely cancels here, okay? And so let's evaluate this limit. It has to be less than 1. So let's evaluate this limit. Okay, so we got x minus 4 and then over 3. So this is going to be x minus 4 over 3 has to be less than 1. Why did I forget the n's? Because they go, that's basically infinity over infinity, which is going to disappear, and I'm left with this. So then that means that x minus 4 over 3 has to be between 1 and negative 1. So then we're going to do 3 and negative 3. And then we're going to add 4 to all sides here. So add 4 is going to be 1 and 7. Okay, and then for which of these is this going to be alternating? This will alternate if this is negative, so that's going to be negative 1. So then this is going to be a less than or equal sign. If x equals 1, it's an alternating series that converges. Okay, so there. Okay, that was all A. Let's talk about B. Find the first 3 non-zero terms and the general term of f prime. Okay, so if f of x is x minus 4 squared over 6 and x minus 4 cubed over 3 times 9, okay, and x minus 4 to the 4th over 4 times 27 or whatever, and then x minus 4 to the n plus 1 over n plus 1 times 3 to the n. Okay, let's take the first derivative of this. So we're going to multiply by 2, and then we're going to get x minus 4 to the 1 power over 3. We're going to multiply by 3. That's going to kill this, and we're going to get x minus 4 squared over 9. Then we're going to get x minus 4 cubed, and we're going to multiply by 4. We get 27. And then we're going to multiply by n plus 1, which is going to kill that n plus 1, x minus 4 to the n over 3 to the n. Okay. So that's B. The Taylor series for f prime described in part B is a geometric series. Well, what do you know? Okay, for all x in the interval of convergence of the Taylor series, show that f prime is equal to that. Okay, so f prime of x. Oh, no, sorry. This is f of x. This is f prime of x. Okay, so let's look at part C. Okay, so we're going to say that f prime of x is equal to the sum, and I'm going to say from n equals 0 to infinity of, gosh, how do I do this? Because it has to be from 0 to infinity. So I'm going to say x minus 4 over 3 to the n. But then how do I get the first term? I have to get the first term by also having an x minus 4 over 3 here to start with, okay? So what is it? It's if s is equal to sum of a0r to the n equals 0 to infinity, then that sum is a naught over 1 minus r. Does that make sense to you? Okay, so this will be x minus 4 over 3 over 1 minus x minus 4 over 3. That's what the f of x prime of x is going to converge to. So now what if I bring this down? And what if I say x minus 4? Now let's distribute the 3. 3 minus x minus a negative 4. Okay, so there you go. There's your x minus 4 over 7 minus x. There it is right there. Okay, all good. It is known that the radius of convergence of the Taylor series for f about x equals 4 is the same as the radius of convergence of f prime. Yeah, okay. Does the Taylor series for f prime described in part B converge to f prime at x equals 8? No, because that's outside your radius of convergence. The radius of convergence is 3. Okay, so the radius of convergence is 3. All right, so let's talk about this. I'm not going to write out. I'm just going to say no, and so there's a couple of reasons why. One, the radius of convergence is 3. There it is, and from 4 to 8 is outside the radius of convergence of 3. Let's also talk about this right here. Let's look at this term right here. What if you plug in x equals 8? If you plug in x equals 8, you get 4 to the n over 3 to the n, and that will diverge because that is a geometric series where your common ratio is greater than 1. So that's my story, and I'm sticking to it. All right. Well, thank you for sitting through this long video of solutions to the AP Calculus exam problems.